Let's talk about a very interesting disease, African sleeping sickness. So, African sleeping sickness is caused by this parasite. This is known as Trypanosoma brucei, or just the parasite that causes the sleeping sickness. It is spread through the bite of a tsetse fly, or this guy up here, and they live in a bunch of areas in Africa. So, like many parasites, T. brucei does have a very complicated life cycle. I'm not going to go over all the stages. If you want, you can pause and read the stages, but I'm not going to go over it because that's a lot of things. Different parts of the body are affected by this parasite, including your skin, your blood, and your lymph nodes, which are responsible for your immune response, as well as, in severe cases, the brain and cerebral spinal fluid, which isn't great. So symptoms of African sleeping sickness can range pretty widely. Some people get skin rashes, as well as, nausea, dizziness, fatigue, a pretty extreme fatigue, which is kind of where the name comes from, as well as pretty severe head and muscle aches, as well as swollen lymph nodes, so around here they just kind of swell up because this can affect the lymph nodes, as well as causing fatigue on its own. Some studies have also shown that this parasite can disrupt sleep schedule and mess with your circadian rhythm, which even adds to the fatigue even more. So yeah, overall, just not a fun time. As with many infections, this can either be a long-term chronic infection with symptoms and issues lasting years, or a short-term acute infection in which it's shorter but often can be more severe depending on the individual. One interesting thing that this parasite does, as well as a couple other different pathogens, is they have a very interesting way of evading the host immune system. So every type of pathogen has these different things on them called antigens, which are used to be recognized by the immune system so it can start off an immune response. So ideally for the pathogen, you don't want your antigens to be recognized, because if the immune system doesn't recognize the antigens, then it can't get rid of the infection, which is good for the pathogen, bad for the host. So what some pathogens do, including T. brucei, is antigenic variation, where periodically the parasites will shed their antigens and regrow essentially new ones that are different from the ones that they previously had that could be recognized by the host. So the host has to go through the entire immune response again because there's different antigens now, and so they have to just restart over from scratch basically. And this is good for the worm because it basically gets a free pass throughout the host body until the immune system starts to recognize these antigens again and get the whole immune response going, in which case these guys will shift their antigens again, essentially just going around and around in circles trying to confuse the immune system, at which point, in some severe cases, the immune system can just get exhausted and it can't keep up with the antigen variation, so it kind of just gets overwhelmed, at which case the infection likely becomes fatal if left untreated with medication. So a very smart strategy on the worm's half, but not great for the host because if left untreated, they will probably die. Now, there are medications that can be used to relatively easily clear these infections. However, it is most common in less wealthy countries, so a lot of places in Africa that don't have access to the necessary medical care. So if left untreated, it has a pretty much 100% mortality rate, which is not good. Quite a lot of people die from African sleeping sickness every year because they don't have access to the proper treatment, which is very sad. So, yeah, here's another very interesting disease. If you're traveling in Africa, take precautions to not get bit by flies and mosquitoes, because those diseases are not fun.